lesson going to be on exponential logarithmic equations. I'm going to start out by talking about exponential equations. Here's an exponential equations, and you can see the x is on the exponent, so that's why it's called an exponential equation. Our goal is to solve for x, and the way to approach this is we're going to look at the number 9 to start with, and we ask ourselves, how can we break number 9 down? We can break it down as 3 times 3. So in other words, instead of writing 9, I can write 3 to the second power. So this would be 3 to the second power times 8 minus x. And if I do the same thing for 27, or break down 27, what should numbers give me 27? It will be 3 times 9. And then 9 can be written down as 3 times 3. So in other words, 27 can be written down as 3 to the third power times x minus 3. The reason why I want to do this is because now these two sides of the equation have base 3. So because these bases are the same, I can set the exponents equal to each other. If these numbers were not the same, I could not do that. And because these two are the same, I can write then 2 8 minus x equals 3 times x minus 3. So now this becomes 16 minus 2x, and this becomes 3x minus 9. Now this is a very simple equation. All I have to do is move the 3 to that side, and make sure I move the 16 to the other side. Okay. When I move this 3x to the other side, it becomes negative 3x. And the 16, when it moves to the other side, becomes negative 16, and then you bring down the negative 9. So then I'm going to have here negative 5x equals negative 25, and last step, divide both sides by negative 5, x then equals 5, and that's our answer. Let's go ahead and move to problem number 2 now. Okay, as you can see, the bases are not the same, so I cannot set these two equal to each other yet. But if I take a closer look at number 8, and I try to break it down, this would be 2 and 4, and 2 and 2. So that means 8 can be written down as 2 to the third power, and this would be 2x plus 6. Now that they have both the same base, you can write 3x equals x plus 6. And then to solve for x, all I have to do is move the x to the other side, so it will be 3x minus x equals 6. This will be 2x equals 6. Divide both sides by 2, x equals 3. Let's go to example number 3 now. Try to break down 200. I'm going to see that this will become 10 times 20. You can break down 10 as 2 times 5. And this would be 4 times 5. 2 times 2. So in other words, 200 can be written as 2 to the third power times 5 to the second power. The problem we have here, and that is different than the ones before, is that now I have two bases, and I just want one base. So we're going to have to find another approach to solve this equation. And the approach that we're going to use is we're going to do the following. We're going to do logs on both sides of the equation, and as long as you do on both sides, you can do that. Then, one of the properties of logs that we learned on the previous class is that you can take the exponent of the log and move it to the front. So this now becomes x minus 2 the log of 5 equals the log of 200. Now, what we're going to do is we're going to divide both sides by log of 5. What happens here is these logs cancel. I'm left with x minus 2. And over here, I'm going to take a calculator and press log 2, 0, 0, close parentheses, divided by log 5, enter. Okay, and when you do that, you're going to get 3.292. For the purpose of this class, we are going to round our numbers to 3 decimal places after the decimal point. Okay, and the final step is to solve for x, so we're going to move the 2 to the other side. So this will be 3.292 plus 2. So my final answer is 5.292. So let's go ahead and try problem number 4. Again, I cannot write with the same base, so that means I'm going to be using logs. I'm going to do logs on both sides. And next thing, I want to move the exponent to the front. So x minus 1, the log of 4 equals the log of 5. Now we want to divide both sides by the log of 4. And then log of 5 divided by log of 4 will be 1.161. And move the 1 to the other side, so this will be x equals 1 plus 1.161. So x equals 2.161. And that's my final answer. Now we're going to talk about logarithmic equations. And the thing that you want to do when doing logarithmic equations is make sure you only have one log, like this one here. It's kind of different than here. Here I have 2 logs. So first step is to get just one log, like this one. And we focus at the base. The base is 3. So what we're going to do, we're going to write base 3 on both sides, because this is a log of base 3. And we're going to use the log as the exponent, and this 2 as the exponent. Okay? So I wrote the same thing, but instead of writing on the bottom, I wrote them on top as exponents. Okay? The reason why I do that is because if you remember last class, we talked about if you have the base raised to a log of the same base, then this whole thing here becomes the exponent, which is x minus 5. I shouldn't say the exponent, but this x minus 5 right here. Okay? And then this 3 second power is 9. And guess what? You can solve for x. X will be 9 plus 5. X equals 14. Now let's look at example number 2, where you have 2 logs. What we're going to do, our first objective is to get just one log. And if you remember, we do have a property that says if you have the logs of the same base, which in this case here is the invisible 10 that we talked about before, Right? Since they have a base and there's a subtraction, you can rewrite this as log of 45x over 3 equals 1. And if you want to put a 10 there, that's fine. Alright? And that will be the same thing as log base 10 of 15x equals 1. Now that we have this as one log, we can rewrite it by using base 10 on both sides and using the log as the exponent. This here will be 1. Now if you remember, you have base 10 raised to a log of the same base. It's going to be equal to the 15x. And this would be 10. Now divide both sides by 15. And what your numbers goes into 10 and 15, that is 5. So that means this fraction reduces to 2/3. Okay, now we're going to proceed and do problem number 3, which is the log of base 4 x squared equals 7. Okay, in order to solve this problem, we'll look at the base. The base is 4, so that tells us that we're going to use base 4. Okay, then we're going to use these over here to for my exponent. So this would be the log of 4 x squared, and here will be the exponent 7. Okay, and that's exactly what we want, because we want to make sure that the base equals the base of the log, and if that's the case, then this whole thing can be rewritten as just that x squared. Okay, and that's what we're going to do. And then 4 to the 7th power is 16,384. How do I get the x alone? I'm going to take the square root of both sides. Remember to put positive and negative. The square root cancels with the square. That's x alone. And if you punch this number in the calculator, this will be 128. Some of you might ask, how do I put this in the calculator? Basically, you press second, you press the button that has x squared. On the very top you'll see the radical sign. And then you press the numbers 1, 6, 3, 8, and 4, and then press enter, and that will give you the answer, 125. I'm going to give you a few seconds for you to copy the problem. While you do that, I'm going to copy problem number 4. Number 4 is 3 equals the log of 8 plus 3 log x. Alright, so here we go for problem number 4. Okay, on this problem we see that we have 2 logs, and our goal is to have only 1 log. Okay, so basically I have to use my properties to make sure to write into 1 log only. Well, first thing I'm going to do is, I see this 3 here, I'm going to send it back into the log. So this will be the log of 8 plus the log of x cubed. Alright, now that I have coefficient 1, this invisible 1 that's over here and over here, I can combine this as 1 log. So this would be the log of 8x cubed, because remember, if it's adding, these two numbers are going to multiply when I combine them, and that's what happened there. Also remember there's an invisible 10 there, so this is a base 10 log, and that's important because that tells us that I'm going to use 10 on both sides of the equation in order to solve for x. So I start with base 10 on both sides, and I'm going to use these as my exponents. So this would be log 10 ax cubed Alright, now that I see that I have base 10 raised to a log of base 10, these two numbers are the same, that tells me this whole thing can be rewritten as just 8x cubed. Okay, so this would be 1000, and this would be 8x cubed. So we're, sorry, can you see it? 1000 equals 8x cubed. Okay, now we want the x alone, so we're going to divide both sides by 8. Okay, we're running out of space, I'm going to bring it down up here. 1000 divided by 8 is 125 equals 8 divided by 8. The 8 cancels, so you're left with x cubed. Now what we need to do is get the x cubed alone. So what we're going to do is we're going to do the cube root on both sides. The x is left alone, and cube root of 125 is 5. Some of you might be wondering, how do I do cube root on the calculator? Basically, you press the button that says math. When you press that button, there will be, on the window, you're going to see number 1, 2, 3, 4. On number 4, you will see that it says cube root x. That's the one you want, so you press number 4. And then you enter the number 125. And finally, press enter, and that should give you the answer that we're looking for, which is number 5. Okay. So this concludes our lesson on exponential and logarithmic equations. And along with your handout, you will find your homework, your assignment, and as you use these notes, you should be able to do those problems. Okay. Remember to always check the answers on the back of the assignment sheet to double check if you're getting the right answer. Thank you very much for your time and attention.